Page 5 and 6 of normal distribution. First is the last problem continued from last page. If Z is the standard normal distribution, find the following probabilities using technology. In each case, sketch the regions. Okay, so these are actually even easier than the non-Z problems, the X distribution problems, because when you draw these, then you could just think of, oh, I don't even need to write down exactly, the standard deviations are very easily written down because the mean is 0, the standard deviations are all just -1, -2, +1, +2. So when you see -0.86 to 0.32, then it's very easy to draw. -0.86 is here. +0.32 is about here, right? So, and then when you put it in the calculator, you don't even need to second distribution, normal CDF. You don't even need to put in a new mu and sigma. You just put in 0 and 1, which is automatically put in. So I'm just going to put -0.86. And for upper, I'm going to put 0.32. Paste. And I get 0.431. Okay? And then for C, Z is less than or equal to 1.2. So 1 would be here, 1.2 would be about there. Okay? So I'm going to second distribution, normal CDF, and I'm going to put -infinity to 1.2. -infinity you put in by -1, double E, where's double E? 99, and 1.2. And then I'm going to leave mu 0, sigma 1, because that's for a Z distribution, those are what you want. And the percentage or the decimal is going to be 0.885. Let's do E. E is Z is greater than or equal to 1.3. So 1 would be there, 1.3 would be about there. So you're looking at that region. Second distribution. And then we're going to put from 1.3, 1 EE 99. Paste. 0.0968. Okay. And then last one, Z is greater than 4. This is really hard to draw because if you look at it, here's 0, here's 1, here's 2, 4 is off the screen, so you can't really even draw that. Obviously, this is going to be super small. So we're going to put 4 is the lower limit, right, because the Z is greater than 4. The upper limit is infinity, and then we do paste. Wow, look at that. This is scientific notation with 10 to the -5 because it's got e to the -5. 3.17 times 10 to the -5. Okay? Alright, let's move on to the last section, 24G. Alright, quantiles or k-values. To find A such that P is, the probability of X is less than A is 0.479, we're going to use the inverse normal function. Okay, so we're doing kind of a reverse problem here. Yes, we do know the standard deviation and the mean, but we want to know what is the marker. Like here, we knew that this was 1.2, right? And we later find out that the percentage is 0.885. What they're doing now is they're giving us 0.885. They want to figure out where 1.2 is, and that's what inverse normal does. Okay, so let's do that. Suppose Z is a standard normal distribution. Illustrate with the sketch and find K such that Z is less than K is 0.81. Okay, so let's see. We're going to do second distribution, inverse normal. And we're going to put in that the area is 0.81. The area is the same as like the probability, right? Sigma, well, it's the z just standard normal distribution, so mu is going to be 0 and sigma is going to be 1. So we don't need to do anything else there. And we find out that the answer is 0.878. What does that mean? Well, here's 0, here's 1, so 0.878 would be about there. Okay? So basically what this is saying is the area that is less than 0.878 is 0.81. Okay, let's do the next one. Probability that z is less than k is 0.58. It's probably going to be somewhere around here, right? Because it's about 50%. So we'll do this again. You just like grab this and edit it. So instead of 8.1, I'm going to put in 5.8. Mu is sigma, or mu is 0, sigma is 1. Oops, it's 0.202. Okay, so yeah, it is very close to 0. Next one, 0.17. Let's put 0.17 in here. 17. This is the same thing as if I would do second distribution, and I went into inverse normal, and I put in 0.17, 17% chance. Be 0.954, which is about there, right? 0.954. Okay. Yeah, 17% is like, oh, I wouldn't put, yeah, that was not a good, 0.954. It's negative 0.94. Yeah, no, that was okay. Negative point, I just didn't write the negative. Negative 0.954. Okay. And then the region that's covered is that one, right? Okay. Let's move on. Suppose that x is the normal distribution with a mean of 38.7 and a sigma of 8.2. It gives you the variance, so that's why it's 8.2 squared, okay? Illustrate with the sketch and find k such that, okay, so in this case, we got the mean being 38.7. And then, let's see, it says, what's the probability, or if the probability is 0.9, what's k? That's going to be a pretty big area. 0.9 is like 0.9 of this, so it's like almost to the very end here. Let's use second distribution, inverse normal, and we're going to put in 0.9 for the area, and then we're going to put in mu 38.7. And the sigma we're going to put in 8.2, not 8.2 squared because we don't want the variance, we want the sigma. And it's 49.2. 49.2. Okay. Looking at a sigma of 8.2, this would be about 46, and this would be about 54. So it would be about here, 49.2. Okay, and then finally, the probability that x is greater than k is equal to 0.8. Now, for this one, it's a little bit tricky because they're wanting to know this region here, right? They want to know the region that is greater than k. So if this is 38.7, we're actually looking for a number that's less than 38.7. Because the probability that x is greater than k is going to be 0.8, so it's almost the whole region here. And actually the calculator cannot do this directly, because if you give the calculator 0.8, it's going to find you the opposite region. It's going to find you the probability that, or it's going to find you the region that is left of a line that gives you 0.8. And we want the right of the line. So what we're going to do is, we're going to trick it by, instead of giving it 0.8, we're going to give it 0.2. We're going to give it 1 minus 0.8. And if we do that, then it's going to give us what we want. So we're going to give it 0.2. And the rest of it, 38.7, 8.2, remains the same. And then they'll say 31.8. And so 31.8 is going to be here. Does that make sense? Yes, because 31.8 is to the left of 38.7. Let's see what happens if you put in 0.8 instead, which is maybe a common error. Okay, so it gives us 45.6. Do you see how that gives us a number that's to the right of 38.7? So it really helps to draw this picture, because then it says, oh, I'm expecting a number to the left of the mean, and if it gives you a number to the right of the mean, then you know that you did something wrong. So it's easier to catch mistakes if you draw the picture. Okay. Number 5. The students of class X sat a physics test. The average score was 46 with a standard deviation of 25. The teacher decided to award an A to the top 7% of the students in the class. Assuming that the scores were normally distributed, find the lowest score that would achieve an A. Okay, so he wants 7% of the class to get an A. Okay, so it would be the top 7%. And the average score was 46. Oops, 46. Standard deviation of 25. So this would be about 46 plus 25 is about 71. Okay. All right, so we're going to use inverse normal. And we're not going to put in 7% because that'll think that we're talking about the bottom 7%. Since we're talking about the top 7%, we actually need to, second distribution inverse normal. Oh, man. When you get in this jam, just do second quit to get out of everything. Okay, now do again, second distribution. Okay. And then here we're going to put in, instead of 0.7, we're going to put the opposite, or not 0.7, instead of 0.07, we're going to put in the opposite, which is 93.93. And then the mean is going to be 46, and the standard deviation is going to be 25. And you think EAC teachers are hard. Look at that, a mean of 46. Okay, 82.9. 82.9. So that would be the minimum score to get a 7, for the top 7%. 82.9. Okay, that's going to get you an A in this class. All right, 7. The length of a screw produced by a machine is normally distributed with a mean of 75 millimeters and standard deviation of 0.1. If a screw is too long, it is automatically rejected. If 1% of the screws are rejected, what is the length of the smallest screw to be rejected? Okay, so we're going to draw a picture again. The mean is 75. The standard deviation is 0.1, so this is going to be 75.1. So the left standard deviation mark is going to be at 74.9. Okay, and then if 1% of the screws are to be rejected, we're talking about this 1% up here, right? But this calculator, if we give it 0.01, it's going to think that the 0.01 is the left side of the marker K. So we need to give it 0.99 so that it rightly knows that we're talking about this K up here, not the K down here. So we're going to put 0.99 into it. Second distribution, inverse normal, 0.99, 75, and the standard deviation is 0.1. And it gives us 75.23. Okay? So what is the length of the smallest screw to be rejected? 75.23. Okay. Next page and last page. The volume of a cool drink in a bottle filled by a machine is normally distributed with mean 503 milliliters and standard deviation of 0.5 milliliters. 1% of the bottles are rejected because they are underfilled, 2% of them are rejected because they are overfilled, otherwise they are kept for retail. What range of volumes is in the bottles that are kept? Okay, so 503 is the mean, and standard deviation is 0.5, so this would be 503.5, this would be 504, this would be 502.5, this would be 502. 1% of the bottles rejected because they are underfilled, so that would be this part here. 2% are rejected because they're overfilled, which would be here. Okay, so let's do 1% first. This is 1%. This is 2%. And so we'll do inverse normal. And we're going to put in that it's the bottom 1% because the bottom 1% are rejected. And the standard deviation is 503. And the sigma is 0.5. Okay. 501.8. So the bottom 1%, this K here, is 501.8. And then what about this marker here? We can't put in 2% because it's going to think we're talking about the bottom 2%. What we want to put in is the opposite of 2%, which is 98%. 98%. It's going to be 504. Okay? Alright, so the range of the bottles that are kept are between 501.8 and 504. Okay. Number 1. The IQs of students at school are normally distributed with a standard deviation of 15. If 20% of the students have an IQ higher than 125, find the mean IQ of students at school. Okay, so these are problems where a little bit different than what we've done before. Now we know the percentage. Now we know where the K is. We don't know where the mean is, for example. Okay, so let's find the mean. So now we don't know what this is. We're finding that. Standard deviation is 15, so we know each one of these divisions is 15, right? And they tell us that 20% of the students have an IQ higher than 125. So we know that the marker here is 125. So K is 125. And we know that the area is 20%. 20% have an IQ higher than 125. This is 20%. Okay. And now we learn exactly why we've been looking at Z distributions, because the way to do this problem is with Z distributions, because there's no function on the calculator to do this with an X distribution. Okay? Now, if they give you this problem where the mean is 0 and the standard deviation is 1, everything becomes a lot easier, because you already know that you already know standard deviation is 0 or standard deviation is 1 and the mean is 0. So you can figure out the Z position relative to the mean easier. And that's what we're going to do. You still don't know what I'm talking about. That's okay. Okay, so what we have here is 20% and 125 as two of the critical things that we need to know. Let's start with 20%. If this was a Z distribution where the mean is 0 and the standard deviation is 1, -1, etc., let's figure out first where this marker is on the Z scale. Okay? So if we're looking for the right 20% here, that's the same thing as left 80%. So let's assume that this is a Z distribution problem, and then we'll do second distribution and do inverse normal, and then we're going to say 0.80, and we're going to say that the mean is 0 because this is a Z distribution problem. Sigma is 1 because it's a D distribution problem, and it'll tell us that if this was a Z distribution problem, that this marker is actually 0.841. Okay, I kind of drew it a little bit too far to the right, because 0.841 is actually here. Okay, so we know that 20% would be at the Z equals 0.84 mark, which is slightly to the right of the mean. Now that we know what the Z variable is, we could use the Z transformation, which is Z equals X minus mu divided by sigma, to find out what the mu is, right? Because we could use Z as 0.841. X, we already know is 125. Mu, we don't know what it is. And sigma, they told us, is 15. So now we just use algebra to solve for mu. First thing we're going to do is multiply both sides by 15. 0.841 times 15 is 12.6. then I'm going to subtract 125, and I get that it's negative 112. So negative 112 on the left, negative mu on the right. So actually mu is equal to 112. That's pretty good. Actually, the average IQ is considered to be 100. So the IQs of this school, the average is 112. So that means higher than average. The weekly income of a bakery is normally distributed with a mean of 6,100. If 85% of the time the weekly income exceeds 6,000, what is the standard deviation? Okay, so this time we know the mean is 6,100. We don't know the standard deviation, but we're going to find it the same way as before. We're going to find out the z value, and then we're going to use the z transformation to find out what sigma is in this case. Okay. So 85% of the time, the weekly income exceeds 6,000. Okay, so actually, we know that if this is 6,000, 85% of the people are to the right of that, 85%. Okay, so now we can use the inverse normal function, second distribution, inverse normal, and we're going to put in, we're going to assume that the mean is 0 and the standard deviation is 1. And then we're going to use the fact that we're going to find out what this distribution of 85% to the right of the line, what would 6,000 be in z terms. So let's put in, we're not going to put in 85% because it's 85% to the right. We want to put the 15% on the left because that's the only thing the calculator understands. It only understands if you give it the left side. So we're going to give it the left side. Mu and sigma are going to be 0 and 1 because we're trying to find out what the z equivalent of 6,000 is. It's negative 1.04. So now we know we can use this formula, right? And we know that z is negative 1.04, and we know that x is 6,000, and we know that mu is 6,100. We just don't know what sigma is. So now we can just rearrange algebraically. We could put 6,000 minus 6,100 is negative 100, of course. And go through the algebra slow, and you'll see that this is fine. Okay, 100 divided by 1.04 equals 96.2. So the standard deviation is 96.2. All right. Number 5. Find the mean and standard deviation of a normally distributed random variable x, given that the probability that x is greater than 80 is 0.1, and the probability that x is less than 30 is 0.15. Now in this one, it's even more tricky because they don't give us the mean or the standard deviation, but we're going to go about it the same way. We're going to assume that it's a z distribution first, and then go from there. So it says that the probability that it's greater than 80 is 0.1, which is 10%. So here, this is going to be about 10%, right? And then the probability that's less than 30 is going to be 0.15, so this side's going to be 15%. Okay, and they want to know, what's the standard deviation and what's the mean. So let's figure it out in z terms first. So we can figure out what the z values are for these 2 points and then do the transformation to see that they correspond to 80 and 30 and find out what sigma and mu are because we're going to have 2 equations and 2 unknowns. So first let's figure out, in a z distribution, the left 15%, inverse normal, the left 15%, oh, we already did this. It's going to be negative 1.04. So this number here is going to be negative 1.04. Okay. And then what about the right number? Instead of putting 0.10, what we're going to do is we're going to put in 0.9, right? Because that's the left area. The left area is 90%. It doesn't want us to give the right area. And it's going to be 1.28. Okay. And then we're going to use the fact that we know that the left one is negative 1.04 and the right one is 1.28. And we're going to plug it into the equation z equals x minus mu divided by sigma. So we're going to have, first we're going to have negative 1.04 equals x minus mu, which is, we don't know, divided by sigma. And we know that the x on the left side is 30, right? So this x is actually 30. And the other one is going to be 1.28 is equal to 80 minus mu divided by sigma. And now we have two equations, two unknowns, and we could use algebra to figure out the mu and the sigma that goes with these in this situation. So let's do this. We're going to figure out both of these in terms of sigma. So we're going to rearrange this algebraically through like cross multiplication, and we're going to get sigma equals that. And then we're going to get here that sigma equals 80 minus mu divided by 1.28. And then we're going to set these equal to each other, right? 30 minus mu divided by negative 1.04 is equal to 80 minus mu divided by 1.28. Now we can kind of cross multiply. We get 1.28 times 30 minus mu equals negative 1.04 times 80 minus mu. And then this would be 1.28 times 30. This is just a big algebra problem. 38.4 minus 1.28 mu is equal to, and negative 1.04 times 80 is equal to 83.2. It's negative 83.2 plus 1.04 mu. Okay. And then we're going to add 1.28 mu to both sides. And we're going to add 83.2 to both sides. And so on the left side, we're going to have 38.4 plus 83.2, which is 121.6. And that's going to be equal to 2.32 mu. And then we're going to say 121.6 divided by 2.32 is 52.4 mu. So our mu is 52.4. And then to find the sigma, all we need to do is choose one of the equations and substitute it back. And so let's use like sigma equals 80 minus 52.4 divided by 1.28. Sigma equals, okay, oh, it's not 8 minus 80, it's just 80. So 80 minus 52.4 divided by 1.28. 21.6. Okay. So, the sigma value is going to be 21.6, and the mu is going to be 52.4. That was a lot of work, wasn't it? Oh, and the part B. We didn't do part B. In a math exam, it was found that 10% of the students scored at least 80, and no more than 15% scored under 30. 10% scored at least 80, and 15% scored under 30. Okay, so that's kind of what they said already here. Assuming that the scores are normally distributed, what proportion of students scored more than 50%? What proportion of students scored more than 50? Scored more than 50. Okay, so basically what they want us to do here is they want us to do a regular normal distribution problem and use the mu and the sigma that we just got. Okay, so we're going to use second distribution, normal CDF, and we're going to say, okay, we're talking about what proportion of students scored more than 50. So we're going to put lower limit 50, upper limit infinity, and the mu is going to be 52.4, and the sigma is going to be 21.6. And the answer is 0.544. Okay? The proportion of students that scored more than 50 with this mu and sigma is going to be 0.544. Last one. Circular metal tokens are used to operate a washing machine in a laundromat. The diameters of the tokens are normally distributed, and only tokens with diameters between 1.94 and 2.06 will operate the machine. Find the mean and standard deviation of the distribution, given that 2% of the tokens are too small and 3% are too large. Okay, so 2% here, 3% here, and we're supposed to find the mean and the standard deviation. So this is going to be 1.94. This is going to be 2.06. And let's find the z values that give you 3% here and 2% here. So we're going to do second distribution, inverse normal, and the area is going to be 0.03. We'll start with the left one because it's easier. 0.03, yeah. And then sigma, mu and sigma are 0 and 1. And so it's going to be, the z value is going to be negative 1.88. Now let's find the z value for the 2% up there, except for you can't give it 2%. You have to give it the opposite of 2%. You'd have to give it 88%. Because that would be the left area that corresponds to the right area of 2%. I'm sorry, it's not 88%, it's 98%. 98. So it's 2.05. So the z value here is 2.05. Okay. So now we have two equations and two unknowns. We have z equals x minus mu divided by sigma. So first we're going to have negative 1.88 equals x, which is 1.94, minus mu times sigma. And then the other one we have 2.05 equals x minus mu divided by sigma. And instead of doing that horrible algebra that we just did, I'm going to show you how to use poly-SMLT to solve these equations. So the first thing you need to do is you need to arrange it so that you have something x times plus something y equals something. So I need to get the sigma out of the denominator first of all. Oh, I'm sorry, this x here is not x, it's going to be 2.06, right? 2.06. So this is going to be 2.06 minus mu. Okay, so we got this equation and we got this equation. Now what we need to do is put the mu on the other side. So we're going to have negative 1.88 sigma plus mu equals 1.94. And the other equation is going to be positive 2.05 sigma plus mu equals 2.06. And now we're going to put these equations into the calculator. The way we do that is we insert the coefficients. So we're going to put this coefficient, 1 and 1, because if there's no coefficient, it's 1, right? And these numbers into poly-SMLT. The function in poly-SMLT that we want to use is simultaneous equation solver. We have two equations with two unknowns. Let's press next. We're going to put in negative 1.88. Then we're going to, 1.88. Negative 1.88. Okay. And then here we're going to put 2.05. And then here we're going to put 1. And here we're going to put 1. And here we're going to put 1.94 and 2.06. 2.06. Solve. And it gives us these fraction answers, which we probably don't want. So let's go into main. Actually, we want to get, okay, I want decimal answers. Okay, now I want to solve. Okay, so now I see that the first variable, and this is the first variable because that's the first coefficient that we put in, that's the second variable. So the first variable is equal to 0.031. So sigma is equal to 0.031. And mu is equal to 2.00. Okay, so those are the mu and the sigma. Okay, and then we're going to go to B. Find the probability that at most one token out of a randomly selected sample of 20 will not operate the machine. Okay, so we're trying to find out the probability that 1 out of 20 is outside these measurements and the others are. Find the most oh, it could be 0 too. So we're saying, okay, 0 tokens out of 20 are okay, or one token out of 20 are okay. Any more than that? Nope, there's a problem. Okay, so what is the probability that that, like, on one draw, a token is going to be bad? It's going to be 3% plus 2%, right? So the probability for B, the probability that the event is going to happen is 0.05. Okay, and the number of trials is 20, and the number of times you're looking for it to happen is we call that X or R, is going to be like 0 and 1, right? If it happens 0 times or 1 time, then that's the probability you're looking for. And remember, if you're looking for 0 or 1, then you're going to use binomial CDF function and not binomial PDF function. So we're going to go down to binomial CDF, and we're going to put in that there are 20 trials, that the p-value is 0.05, and the x value is going to be 1 because it's 0 or 1, but 1 is the limit, right? And it's 0.736. Okay, so the probability that x is less than or equal to 1 is going to be 0.736. Okay, and that's it.